Hey everyone. For this video, we're just going to go through the answers to the review sheet that I posted for the energy test. So what I wanted you to do was try the worksheet, try the whole thing, and now you can check your answers. So these are the answers to the whole worksheet. So pause the video or check your answers very quickly. If you got everything right, that's great. You're all set, and you should do well on the test on Friday. If you got a couple wrong, this video is going to go through the whole sheet, like 1 through 13 in order. So you can jump and just skip forward to the ones you got wrong, listen to those, and then jump to the next one, and so on. That way you don't have to sit through the whole thing if you got most of it right. So let's get started. I'm just going to go through the whole thing. An elevator goes downwards at constant speed. What is happening to the potential energy? Alright, potential energy. Anytime I start talking about potential energy, I want you thinking height. What's happening to the height of the object? The higher it is, the more potential it has, and the lower it is, the less potential it has. This elevator is going downwards, and so the potential energy is decreasing. It's becoming less. So anything you wrote along those lines is great. Kinetic energy is a little bit different. That's the energy of motion. Anytime we want to figure out the kinetic energy, what we're going to do is we're going to look at the speed and what's happening to that. This is a constant speed, so the kinetic energy is remaining the same. The speed isn't changing. And that's going to be the idea that we'll use for 2 and 3. Potential energy is related to height, kinetic energy is related to speed. So for number 2. A car brakes to a stop on a flat, straight road. What's happening to the potential energy? Alright, again, potential is height. What's happening to the height? Alright, well, if it's a flat road, I don't think the height's changing if you're on a flat road. So the potential energy is remaining the same. Because again, you're not gaining height, you're not losing height. What's happening to kinetic energy? Alright, we got to think about this a little bit. We brake to a stop. If we come to a stop, it sounds like we're slowing down. If you slow down, then there is less kinetic energy. So I would go with decreasing. 3. A bicyclist goes down a hill while accelerating. What's happening to potential energy? Again, potential energy is height. If you go down a hill, you're not as high up the hill, right? So the potential energy is decreasing. Potential energy is related to height. That's the big, idea here. And kinetic energy is related to speed. Well, if we're accelerating, then we must be getting faster. And if you get faster, the kinetic energy is increasing. Cool. So again, potential energy, height, kinetic energy, speed. That's what affects those two things. 4. Calculate the kinetic energy of an alligator moving at a speed of 2.5 meters per second. So for the test, I'm not going to give you the equations because you have them in your note packet on the last page. But if you look at that, there is an equation for kinetic energy, and it is 1/2 mv squared. We're going to plug everything in here. 1/2. The mass is always measured in kilograms, so equals. So that's the 210 value right there. And the speed is 2.5, and don't forget to square it. So if you do this in your calculator, what you're going to do is the 2.5 squared first, and then multiply it by the other two values. So 2.5 squared times 1/2 times 210. And that will give you an answer of 625.25. joules. Number 5. A 0.2 kilogram bird is at rest on a tree branch. If the tree branch is 3 meters above the ground, how much potential energy does the bird have? Alright, we have an equation for potential energy. It's mgh. So, just plugging in, mass is measured in kilograms. So it's the 0.2. G is always 10, that acceleration due to gravity. And then the height is, I think, 3 meters. That says 3m, 3 meters. Alright, 0.2 times 10 times 3 is 6 joules. That's fine. A 6 kilogram bowling ball is at rest on a shelf located 1.5 meters above the ground. How much potential energy does the bowling ball have? And again, we have an equation for potential energy, so you definitely will need to be able to use these equations on the test. The mass is 6 kilograms. Again, kilograms always that unit for mass. 6 times g, which is 10, times h, which I think is 1.5 meters high above the ground. Alright, 6 times 10 times 1.5 is, I believe, 90 joules. That says, not 70, that says 90. Just is really ugly. 7. A 95 kilogram football player is running at a speed of 3 meters per second. Calculate the player's kinetic energy. And again, we have an equation for that. It's 1/2 mv squared. 1/2, the mass is 95. We know that because mass is measured in kilograms. So that must be the mass. Times v squared. So that's 3. And we're not going to forget to square the 3. When you do your math, you have to do that 3 squared first. So it's 3 squared, which is 9, times 95 times 1/2, and I think that gives you an answer of, I gotta check, sorry, 427.5 joules. So, 427.5 joules. Done. The cliff diver falls down from a very tall cliff. What energy transformations take place as the diver falls? So what I mean by that is energy turns from blank into blank. Well, as you go down the cliff, you're losing potential energy. But the conservation of energy says that energy is never like lost, it just turns into something else. What is it turning into? Well, as you fall, you get faster, which means you're gaining kinetic energy. So the energy transfer that's taking place is the potential energy turns into kinetic energy. So energy is not being gained, it's not being lost, it's just changing its form from PE, potential, into KE, kinetic. Let's do some of the numbers and the math for that conservation of energy. A water balloon has 40 joules of potential energy and 0 kinetic energy when it is dropped from a rooftop. How much kinetic energy does the water balloon have when it reaches the ground? Okay, so, alright, we have an equation for the conservation of energy. It's in your note packet, so again, I won't give it to you on the test, but I'm going to expect you to look it up. It is PE plus KE equals PE plus KE. And remember, when we use this equation, the left-hand side is like before the thing like falls or before something happens, and the right-hand side is afterwards. So before we drop it, it has 40 joules of potential, so 40. Plus, it has 0 kinetic, so plus 0 kinetic is equal to. When it is dropped from the rooftop, how much energy does it have when it reaches the ground? Well, if it hits the ground, the potential energy is 0. And the reason we know that is at the ground, it has no height. Something with no height has no potential energy. Plus, and I think we're looking to solve for KE. I'm going to simplify this. 40 plus 0 is, well, 40. And then KE plus 0, well, anything plus 0 is just itself. Oh man, it looks like we're all done. 40 is the kinetic energy. 40 joules. There we go. 10. A car at rest at the top of a hill has a total of 30,000 joules of potential energy. At one point, on its way down the hill, the car has 25,000 joules of kinetic energy. At this point, how much potential does the car have? Alright, again, for this conservation of energy, we have an equation. PE plus KE before, meaning probably at the top of the hill, before it rolls down, is equal to PE plus KE. Alright, car is at rest at the top of the hill. The fact that it's at rest means it has 0 kinetic energy. It has a total of 30,000 joules of potential. So I'm going to make this 30,000. Alright, equals. At one point on its way down the hill, the car has 25,000 joules of kinetic energy. How much potential does it have? So we're solving for this potential. That's what I'm asking for. That's what I'm interested in. PE plus, and I said it's got 25,000 joules of kinetic, so 25,000 joules of kinetic. Simplifying a little bit, 30,000 plus 0, looking at this left-hand side here, 30,000 plus 0 is 30,000 equals Ke plus 25,000. So to solve for the kinetic energy, what I'm going to do is I'm going to subtract 25,000 from both sides. When you do that, 30,000 minus 25,000 is 5,000 joules of kinetic energy. So that's our answer. Okay, 11. A child jumping on a trampoline jumps upward from ground level with 12,000 joules of 1,200 joules of kinetic energy. At the top of the child's jump, she has 0 kinetic energy. What I would do is at this point, how much potential does it have? What I would do is I would do this. When you jump up, we've got 12,000 joules of kinetic energy. But at the top, we have 0 kinetic energy. All 12,000 joules of kinetic energy is gone. It's not there. Where did it go? Because remember, energy can't disappear. It has to go somewhere. Well, where it went, or the only place it could have gone, is into potential. So the potential energy must be 1,200 joules. And that's it. If you do the equation setup, you should get the same answer. But again, since it lost 12,000 joules of kinetic, it must have gained 12,000 joules of potential. 12. A skier going down a mountain has 3,000 joules of kinetic energy and 11,000 joules of potential energy. Further down the mountain, the skier has 9,000 joules of kinetic energy. How much potential energy does the skier have at this point? Alright. Again, we're doing that conservation of energy. PE plus KE equals PE plus KE. Alright, we're going to do the before and the after. So before, we've got 11,000 joules of potential, so that's it's 11,000 joules of potential plus, I think 3,000 joules of kinetic, which is right here. I'm going to lose my units in there. So we've got 11,000 plus 3,000. Again, that's the potential and the kinetic. Equals. Alright, further down the mountain, we have 9,000 joules of kinetic, and I want to know how much potential. So equals PE plus 9,000. Okay, I'm going to simplify this. 11,000 plus 3,000 is, I believe, 14,000. PE plus 9,000 is just, well, there's not a lot of simplification we can do there. It's just PE plus 9,000. Now to solve, I'm going to subtract 9,000 from both sides, right? Just like an algebra problem. Alright, 14,000 minus 9,000 is, I believe, 5,000. Joules is equal to PE. And that's exactly what I asked for. So this is a good answer. 5,000 joules. Last up, 13. A base jumper, which is like people jump off buildings, with parachutes though, has 70,000 joules of potential energy and 0 joules of kinetic energy when he jumps off the roof of a building. Right as the jumper is about to open the parachute, the jumper's potential energy is 45,000 joules. How much kinetic energy does the jumper have at this point? Again, we're doing that conservation of energy, so that's going to be PE plus KE is equal to PE plus KE. Plugging in, we have 70,000 joules of potential and 0 joules of kinetic before we jump off. So that's 70,000 plus 0 is equal to, okay, right as the jumper opens the parachute, we have a potential energy of 45,000, so that's 45,000 plus, and then we're solving for this kinetic energy. Okay, well, 70,000 plus 0 is just 70,000, right? Equals 45,000. So 70,000 plus 0 is just 70,000, so I'm just going to get rid of this, because it doesn't really do anything, that plus 0. And then, to solve, I'm going to subtract 45,000 from this side, and then 45,000 from that side, because that's how algebra works, right? If you, whatever you do to one side, you have to do to the other side. So, minus 45,000 minus 45,000. And 70,000 minus 45,000 is, I believe, 25,000 joules. Our final answer. Okay, so that's everything. If you're still having trouble, if you didn't really understand what I just did, feel free to go and jump into one of the office hours that I have from 11 to 12 on Tuesdays and Thursdays. Or, of course, you can just email me and I'll send you back like a typed explanation that'll hopefully clarify it for you.